All right, so what we're talking about today is being able to graph linear inequalities. Usually when you graph linear inequalities, the goal is to have it in slope-intercept form. So that's always going to be the first step, is you must solve for y. Now, because we have inequalities, remember if I have a problem that looks like this, oops, it's supposed to say it's this, an inequality. If I have to get rid of this -2 and I divide, remember that when I divide by negative, it flips. So that's a rule we have to remember when we're dividing by negatives. So remember that rule that we used to have for inequalities. When you divide by negative, it flips. Okay? And then after we have y equals mx plus b form, then we're going to graph by plotting the y-intercept, which is the b, and then counting the slope, remember, which is rise over run. Now, the next thing that happens is we have to know what kind of line it is. If you remember back when we did inequalities, if I had x was greater than 2, it was an open circle going to the right. Or if I had x was greater than 2 or equal to 2, it was a closed circle going to the right. Well, we can't have open lines. They're not completely open. Those are going to be dashed lines. And then we could also have solid lines. So a dashed line is when you have y is greater than or y is less than. Those are dashed. And then solid is when they have the line underneath it. When it includes that equal to part, that's a dashed line. Okay, so I could have a dashed line that goes up, and this is y is greater than x. I could also have a dashed line that goes down, and this is this could be y is greater than negative x, because it goes down. And then I could have y is greater than or equal to a positive line, which would be a positive x. Or I could have one go down. Oops, and I keep forgetting. It's early. I'm going to make it solid because it has the greater than or equal to. Greater than or equal to negative x because it goes down. So you can have the lines go all different ways, but what's underneath the line is what tells you whether or not it's solid or dashed. All right, so then the next thing, and this is the thing that can be tricky, is we have to shade above or below based on what's going on. So above is when y is going to be greater than. When it's facing the other stuff, then it's above. For below, it points to the y. So let's do some different examples. Let's say I have y is greater than x, y is less than x, y is greater than negative x, and y is less than negative x. Okay, so I have these 4 lines, and I'm not going to really graph them. I'm just focusing on whether or not I shade above or below. And so a positive 1 over 1x would go up, and it's a dashed line. A positive 1 over 1x would also go up, and it's a dashed line. A negative 1 over 1 would go down. And same thing here, this would also go down. So the first thing I do is I figure out my direction, and those were all dotted because they did not include anything. But now I need to figure out my shading. You see how it says y is greater than? Usually what I'm going to tell people to do is go to the y-intercept and shade above, and that kind of tells you that I'm here, shading above. Same thing here, I shade above, and so it's here. Oops. I just read it wrong. I was going too fast. So this is less than, so it's shade below. This is greater than, and so the line goes a different way, but I'm still figuring out where my above is by looking at the middle and shade above the line. And here, I look at the middle and this says less than, so I shade below the line. Now, the same exact thing works for inequalities that have the equal sign with it, greater than or equal to, less than or equal to. So you graph the line and then you shade the middle above or below, and then that kind of helps you figure out the region. All right, once we've graphed it, the solution area is anywhere that's shaded. It's called the shaded region. So if I have a problem and my solution area is up here, then any point in that region is a solution. Okay, the only ones that are not solutions are the ones that are down here, like this, not a solution, because it's not in the shaded region. Up here, solution. Okay, we got two examples that I want us to do. Again, we have to start off by solving for y, so I'm going to move my 2x. I can't really combine it with the 6, so I put it to the side. So I have 3y is greater than negative 2x. This is a positive 6, so I write plus 6. And I divide by 3. And so I get y is greater than negative 2/3 x plus 2. So my m is negative 2 over 3 and my b is 2. So I'm going to graph those. And again, remember you always start at the b, the y-intercept. So I go up 2. And now I'm going to count my slope. My slope is rise over run. So I'm going to go down 2 and I'm going to run 3. So 1, 2, 1, 2, 3. I'm going to keep doing it. 1, 2, 1, 2, 3. Then I'm going to make it straight, so I'm going to go the other way. I'm going to go up 2 and move the negative to the bottom. So up 2 to the left, 1, 2, 3. Up 2 to the left, 1, 2, 3. Now let's see if I could draw a straight line. Oops, I missed it. So this is supposed to be dashed because it doesn't include it. So I'm going to do the best I can to draw a dashed line that goes through those, and that's pretty good. And then now I have to shade. Well, it says that y is greater than, and so I look at the y-intercept, which is right here, and shade above because y is greater than. And if I shade it above the y-intercept there, that means my solution is this whole entire area. Okay. All right, let's go ahead and do the next one. Again, the first thing you have to do is solve for y. So I'm going to minus 3x on both sides. Again, x's cannot go with numbers, so I just kind of write it to the side. And again, that was a positive 4. So now I have to get rid of this negative 1. And so I'm going to divide everything by negative 1. And because I divided by negative, I have to flip my inequality. So I get positive 3x and a negative 4. So my m is 3 over 1. And my b is negative 4. Again, I start with my b, so I'm going to go down 1, 2, 3, 4. I'm going to count my slope up 3, 1, 2, 3 over 1, up 1, 2, 3 over 1, 2, 3 over 1. There we go. Now this one, it says it equals it, so it's a solid line. So we're going to draw a straight line. And then this time it says y is less than, so I'm going to shade below my y-axis. So my y-axis is here, and I shade below my y-axis, my y-intercept, and that shows me that it's this whole area. Sorry if you hear my dog snoring in the background. She's a little tired. Okay, all right, so when we graph these, again, the first step you have to do is you have to solve for y. Then you're going to graph your y and your y-intercept and your slope, and then you determine if it's a solid or dotted line, and then you figure out your shaded region.